Good morning, students. Myself, Mr. Kiran Bole, going to teach you analytical chemistry, which is paper 4, unit 4, separation methods 1. So basically, analytical chemistry deals with separation, identification and purification of analyte of interest from mixture of various components. As there are n number of unwanted components present with our analyte, separation plays important role in analytical chemistry. Separation can be defined as an operation by which a mixture is resolved into its components. Separation is carried out by various methods such as distillation, recrystallization, filtration, sublimation, precipitation, electrophoresis, solvent extraction, and chromatography, which is nowadays most famous technique. In this unit, we are going to learn solvent extraction and chromatographic methods such as HPLC, that is high performance liquid chromatography, and HPTLC, that is high performance thin layer chromatography. Syllabus: solvent extraction, factors affecting extraction, chelation, ion pair formation, and solvation. Then, graph of percentage extraction versus pH, concept of pH half and its significance. Craig's countercurrent extraction, principle, apparatus and applications. Solid phase extraction, principle, process and application. And then comparison of solid phase extraction and solvent extraction. So let's start with solvent extraction. What is meant by solvent extraction? Solvent extraction is a method of physical separation of a mixture. It can be applied to handle large as well as small quantities of material. The technique is simple, rapid and convenient. It requires simple equipment and is applicable to organic as well as inorganic materials. It also gives good accuracy even at a trace levels. Solvent extraction is nothing but a kind of liquid-liquid extraction in which aqueous solution is brought into contact with second solvent, which can be organic solvent immiscible with the first, in order to bring about a transfer of one or more solutes into the second solvent. Analyte should have solubility in both liquids. Here you can see on the right hand side of the screen apparatus used for solvent extraction called as separatory funnel and how separation is carried out. In this animated video, you can see how actual liquid-liquid separation is carried out using separatory funnel. Separating immiscible liquids. A separating funnel is used for the separation of immiscible liquids of different densities. Examples are oil and water. A separating funnel is a special flask in the shape of an inverted cone. It has a mouth at the top and a stopcock at the bottom. The mixture of immiscible liquid is filled in the separating funnel placed on a stand. It is allowed to stand for some time. The two liquids form distinct layer. The lighter liquid comes to the top and heavier liquid settles at the bottom. Now the stopcock is open and at first the bottom layer is removed. When this is finished, the top layer is removed into another container. Thus, we can separate the two liquids. The quantitative aspects of solvent extraction depend upon distribution law, given by scientist Nernst in 1891. It is also called as Nernst distribution law. According to this law, if to a two-phase system consisting of two immiscible liquids, a solute which is soluble in both is added, then solute distributes itself in both the phases in a definite ratio at a given temperature. In this equation, K is called partition coefficient or distribution coefficient, while C1 and C2 are the concentrations of the solute in solvent 1 and solvent 2 respectively. Now let's see what is meant by distribution ratio. In some cases, solute which is to be distributed in immiscible liquids may undergo either dissociation or association in one or both the liquids. Let's see this with an example of benzoic acid. In first case, benzoic acid gets slightly dissociated into its ions in aqueous layer as shown in reaction, while it gets dissociated, that is, it gets dimerized to form its dimer in benzene as shown in second reaction. So in this case, D stands for distribution ratio and CO and CW are the concentrations of the solute in all its forms in organic and aqueous solvents respectively. Now, separation factor. Separation factor is used when there are two or more solutes present and to be separated out using solvent extraction. Here, beta stands for separation factor. AO and AW are concentrations of solute A in organic and aqueous phase respectively. BO and BW are concentrations of solute B in organic and aqueous phase respectively. dA and dB are distribution ratio of solute A and B respectively. Now in this animation we can see how mixture of two solutes get separated out using solvent extraction. Let's see if we have a mixture of sodium chloride and cholesterol. These are both white crystalline solids, so it mixes together. It may seem impossible to get them separated again, but in fact we can use their physical properties to separate them with ease. Sodium chloride is an ionic compound that is water soluble. Cholesterol, on the other hand, is a steroid, which is a type of lipid and is therefore non-polar and largely water insoluble. However, cholesterol will easily dissolve in a non-polar solvent like ether. So to separate this mixture, we would just pass some water and then some ether. We swirl it around for a while and then pour everything in a separatory funnel. Since these two solvents are immiscible, meaning they do not mix, we will get two layers. On the bottom will be aqueous layer, which contains all of the water and all the sodium chloride which has dissolved and dissociated in the water. On top will be an organic layer which contains all the ether and all the cholesterol which has dissolved in the ether. The water is on the bottom because it is more dense than the ether. So we just open up the funnel and drain the aqueous layer until we just fairly get organic layer, and then we pour it through top of the funnel in another flask. Evaporate the solvents and there we will get our substances separated. Now, exercise. How will you separate mixture of 4-chloroaniline, benzoic acid and 1,4-dibromobenzene into its component using solvent extraction? Thank you very much.